So to be honest with you, I like making these videos because I actually have to do a bit more looking into the topics before I talk about them. And every now and then I actually learn something really cool while doing these videos. Not every video, don't get me wrong, so this is just really germane stuff, but it is kind of cool when I do a video and I actually learn something that I knew it, but I didn't understand why. So it's like E equals mc squared. All of you probably know that formula, but why does E equal mc squared? I mean, you know the sun revolves around the moon, or I'm sorry, the earth revolves around the sun, but why does it revolve around the sun? And so this is one of those videos that I kind of learned something while I was making it. I really liked it. So this video, we're going to talk about capillary pressure. And so what is capillary pressure? Well, first of all, what's a capillary? Well, capillary is a narrow tube. So the capillaries in your bloodstream, those are just narrow blood vessels. A capillary tube is just usually a glass tube, very small, very long and thin. And what we do is we submerge our capillary tube into a fluid. So we have our fluid, and what will happen is that the fluid won't go up to the same level it is on the outside of the capillary as it is inside. It'll either go above or below. Why does it do this? Well, we have to look at two different forces here. Cohesion and adhesion. So cohesion is how attracted molecules in the fluid are to each other. So basically the intermolecular forces between molecules within the fluid. The adhesion forces is how attracted this fluid is to the container material itself. So if we have a situation, we'll say cohesion is C and adhesion is A, where the adhesion is greater than the cohesion. So the fluid is more attracted to the container than it is to itself. What we'll see is that it goes up. And we end up getting a meniscus. So the fluid will climb up the capillary, it'll be concave up. Why does it do that? Well, what's happening is that because these adhesive forces are stronger than the cohesive forces, the fluid is actually drawn up the wall. And it's trying to bind with the wall, it's trying to get as much contact as it can. And the height of this looks like we applied a pressure. So when you want a fluid to go up a straw, you suck on it, right? This is where capillary pressure comes from, is that this fluid will continue to climb the walls until the weight of this fluid is so heavy that it balances it out. Now, the thing is that the narrower the tube is, the more height we can go. So basically what it's saying is that if we have a really fat tube, like something this wide, you won't ever see capillary action because for every millimeter it moves up the glass, it's a whole bunch of liquid that has to move up. That's a huge amount of pressure. But for teeny tiny tubes, for those where they check your blood to see the iron count, it'll actually go up really high because for every millimeter you climb up, there's not that much fluid inside the tube. So if adhesion is greater than cohesion, we get a positive capillary pressure. It'll climb until basically the liquid's weight outweighs the attractive forces going up, and the height it climbs, the actual number, is going to be inverse to the radius of the tube. What happens if we have the other extreme? Cohesive forces are greater than adhesive forces. Well, what will happen is that the liquid will actually pull away from the wall. And what we'll see is that we have a downward facing meniscus. So we have our fluid, and it is actually beneath the level of the fluid outside the container. Again, we have a capillary pressure now, but in this case it's a negative capillary pressure. We're pushing down the fluid using a pressure. And we'll push it down until the height of the fluid outside the straw balances it out. We're trying to push it back up. And it'll be the same relationship. If we have a big fat tube, we won't see much of this depression down, but if we have a teeny tiny tube, basically we can stick the capillary tube into the fluid and it would never actually go into the fluid, into the tube. So capillary pressure, capillary force, all come about from these differences in adhesion cohesion. And again, if it goes up, it's more attracted to the wall, adhesion forces are stronger. If it goes down, cohesive forces are stronger. And this is going to depend on the radius of the tube. The smaller the tube, the more pronounced we're going to see these effects.